Assalamualaikum warahmatullahi wabarakatuh. My name is Hani Shazwani binti Ramli, matric number AP190460. I would like to present about the introduction of our project for railway bridge. Railway bridge are specific structures requiring a deep knowledge not only of structural engineering but also of the operation and safety requirement of lines used daily by great numbers of passengers. In the worldwide, a lot of bridges have been constructed or are now being constructed. However, the deterioration of bridge and the increase of design lifelong due to the industry growth make people feel need for the structural integrity assessment of the structures. Load carrying capacity is one of the widely used structural integrity index for the bridge rating and maintenance.
Assalamualaikum and hi, my name is Nur Safira binti John Azhar, matric number AP190465. I will continue my part in the structure bridge model. In this project, we have designed a model of bridge that display of structure modeling for the design bridge with the following specification required for the bridge project. For the next pipe bridge model, we're using a Limpro software for the support. We use pinet and vertical support at 2 meter front and the back length of bridge. And we also apply the distribution load on which is 20 kN per meter for overall length of bridge, which is length 10 meter. To determine the deflection line, we can see the result of the deflection area at the center span of a bridge was found to be negative 0.000240. As a result, for the internal forces shows here at each member is a red color known as tension and the other color is known as compression. And then we get the details value from the analysis result for each member, and we can see that there are some negative and positive to knowing that the area of tension and compression of the internal force of the structural pipe. And we can see here the value for modulus of the elastic, which is 20.0000, and as a result the support reaction at each two support is 100 kN. The next part is we have to determine the internal forces of all members of bridge with count the external forces in calculations. This is the internal forces in this bridge model doing our calculation. As we can see, the member is divided into each member of joints, which is A, B, C, D, E, F, G, and H to calculate. And then we get the final result of tensions and compression as stated in our calculation results. That's all from me. I will pass to the next presenter. Thank you.
For this presentation, is how the features and class bridge for our group project. So, before I start presenting, let me introduce myself first. So, my name is Siti Nizar with project numbers AP1003 and 4 from group 17. So, what should I do in this video? I should draw the final ratio man and deviations. So, this is our model. This is our bridge with the one truss. So, for the top and the bottom chord, we choose gray color, and for the middle chord, which is this part, we choose tan color. So, this is the view for the 3D view. Okay. So, for the elevations, the range between lower chord is 2 meter. Okay. And between B to B is 1 meter. Okay. The length for the floor is 10 meter. Okay. 1 for the middle. Okay. For the top part is 8 meter, and the lower chord is length 10 meter. A gap before we start call, before we start running a call, this one meter, we, uh, we give that 1 meter. So the height for this bridge is 3 meters. Okay, then a gap and a gap for this cord and this cord is 2 meters. The length for this bridge is 10 meters. That's all from me. Thank you.
Hi and Assalamualaikum to Dr. Hamidun and my fellow friends. My name is Donasin Azma binti Hanwar, AP190482. I will continue with next part, which is the calculation to find the internal force of bridge. So the first thing, we need to find direction of this bridge. As usual, we need to find AX, AY and HY. So for AX, we get negative 20 kN, while for AY, negative 20 times 6 plus HY times 8, and then we solve it until we get HY equal to 15 kN. For AY, negative 20 plus AY plus HY, which 15, and we get the answer of AY is 5 kN. Next, we go through to find all the internal force of this bridge, which is we need to go one by one. Take a look at point A. We need to find kilonewton of AB and AC. For AB, 5 plus AB since 45 equal to 0, and then we solve it until we get AB equal to negative 7.071 kilonewton. For AC, we use cos 45, which is the answer 4.99 kilonewton. Next, for point B, we need to find the value of BE and BD. For BE, we put in the answer of AB, which is 7.071 since 45 minus BE since 45, and we solve it and get the answer 7.07 kilonewton. For BD, just put the answer of BE in the formula and we use cos 45, then solve it until we get the answer negative 7.07 kilonewton. Point E, we need to find EF and EG. As usual, the calculation for EF is same like BE, but we need to change the alphabet, and the answer we get is negative 7.071 kilonewton for EF, while EG negative 4.99, which the value from AC minus negative 7.07 cos 45 minus 7.071 cos 45 plus EG, and we solve it until we get 12.07 kilonewton. For point F, we need to find the value of FH, which 7.07 since 45 minus 20 minus FH since 45, and we solve, then we get 21.213 kilonewton. Last, for the point H, which we need to check whether get same light reaction or not. So negative 21.213 since 45, which is from the value FH plus 15, and we get the same light direction. So that's all from me, and I will pass to the next presenter.
Next is recommendation on how to improve the bridge load carrying capacity. First, bonded steel plate tendon reinforcement method. Steel plate reinforcement bonding method is using epoxy resin structural adhesive, bonding the steel plate or steel on concrete flexural members and form together so as to achieve the improve the bending resistance and shear resistance of the component and reduce the effect of crack propagation. Second, pre-stressing FRP reinforcement method. Improve the bearing capacity of bridge structure, has incomparable advantage in large span beam slab of flexural reinforcement, then significantly reduce deformation of the structure and improve the bearing capacity of structure, decrease the crack width and deflection deformation, and it's suitable for large span beam slab of flexural reinforcement. Then improve the stiffness of structure and make full use of the material performance, save a lot of materials and engineering costs. Third, enlarging member section and reinforcing reinforcement method. When the strength, stiffness, stability, and crack resistance of the beam are not enough, the reinforcement method can usually be used to increase the section of the member and increase the reinforcement. The enlargement of concrete cross-section can be adopted as follows. Thickening bridge panel, then increase the height and width of the beam rib of the main beam. Main point of construction of main reinforcement bar method is reinforcement of main steel reinforcement, Connecting long stirrup and restoring concrete protection layer. Fourth, reinforcement method of rebar planting. Epoxy metal for rebar connection and heavy anchoring. Structural connection with post-install rebar. For example, extension or connection to wall, slab, stairs, column, foundation. Then, structural renovation of building, bridge and other civil structures. Retrofitting and re-strengthening of concrete members possible. Then, anchoring structural steel connection, such as steel column and beams. That's all from me. Thank you.